Session 3.2. Describing and presenting data Deck 16. Learning objectives. At the end of the session, the learner/S will be able to explain and identify the appropriate means of presenting data. Identify and distinguish various measures of central tendency, dispersion, and location. Explain the use and considerations in constructing graphs and tables, and explain the advantages and disadvantages of using certain data presentation methods. Data presentation. Definition. Aims to communicate information about the data in a clear and effective manner. Has three forms which include textual or narrative, tabular, and graphical presentation. Whatever method of presentation is used, it should allow the viewer to think about the data conveyed and avoid distortion of the data. Diastolic blood pressure of residents of Varanasi X. ASCII. Alt. Textual presentation. Definition. Also called narrative presentation. Uses statements with few numbers in order to describe the very important data characteristics. Complements data presented as tables or graphs. Often used to highlight results or convey significant findings in the discussion or conclusion sections. Advantages versus disadvantages. Advantages. Emphasizes significant figures or values in the findings. Increases recall and understanding of important findings in a study. Disadvantages. Incomprehensible with large data in the text. Can be tiresome when same words are repeated. 81.06 mmHg, the mean diastolic blood pressure of residents in Varanasi X 60 to 110 mmHg, the minimum and maximum diastolic blood pressure of residents. 10.62 mm Hg, the standard deviation of the diastolic blood pressure of residents. ASCII. Alt. Measures of central tendency. Definitions. Measures that indicate where the center or the most typical value of the variable lies in collected set of measurements. Can be used to refer to typical values. The most common measures include the mean, median, and mode. Mean. Also known as the average, usually expressed as XX bar. Involves all observations in the computations. Median. Refers to a point in the distribution that divide the observations into two equal parts. Not easily influenced by outliers or skewed data. Mode. Refers to the most common or frequent value in an array. Can be determined for both quantitative and qualitative variables. How to compute the mean. ASCII. Alt. The mean diastolic blood pressure of adult residents from Purik 1 of Varanasi X was about 80.56 mm Hg. How to compute the median. ASCII. Alt. About 50% of residents living in Purik 1 had a diastolic blood pressure of 80 mm Hg or less, while the other half have higher values. ASCII. Alt. About 50% of the entry-level healthcare workers weigh 56.5 kilograms or less, while the other half weigh more than 56.5 kilograms. How to compute the mode. ASCII. Alt. The most common weight among entry-level healthcare workers was 48 kilograms. ASCII. Alt. The most usual diastolic blood pressure was 80 mm Hg among residents of Purik 1 in Varanasi X. Measures of dispersion. Definitions. Measures that give information about the tendency of the values to clump together. May only be used for quantitative variables. Most common measures include range, interquartile range, and standard deviation. Range. The difference between the highest and lowest values, observation, in a data set. Simplest measure of variability. Interquartile range. The difference between the 25th and 75th percentiles of the variable. The IQR gives the range of the middle 50% of the observed values. Standard deviation. The most frequently used measure of variation. Denoted as SD or plus or minus. Refers to the square root of the variance. How to compute the range. ASCII. Alt. Range equals maximum, minimum. Equals 90 to 60 equals 30. The diagnostic blood pressure of residents of Purik 1 was between 60 mm Hg and 90 mm Hg, or a range of 30 mm Hg. How to compute the interquartile range. ASCII. Alt. IQR equals P75, P25 equals 90 to 80 equals 10. The diagnostic blood pressure of residents of Puric 1 has a median of 80 mm Hg with an interquartile range of 10 mm Hg. How to compute the standard deviation? ASCII. Alt. S equals square of 1200/16 equals square of 75 equals 8.66. The mean diastolic blood pressure of the adult residents was 80 plus or minus 8.66 mm Hg among those living in Varanasi X. Tabular presentation. Definitions. Provides a compact way of presenting large sets of information. Has various purposes in the research process. Has prime considerations specifically simplicity, clarity, and directness. And its construction involves certain pointers such as position of the table, uniformity of style, number of variables, and complexity. Advantages versus disadvantages. Advantages. Concise and easy to understand. Facilitates analysis of categories of the given variable. Disadvantages. Too many rows and columns equals difficult to understand. Requires more time to construct and interpret. Ideal table. Table title and number, stub, box head, body, footnotes. ASCII. Alt. One-way table. ASCII. Alt. Two-way table. ASCII. Alt. Multi-way table. ASCII. Alt. Two-way contingency table. ASCII. Alt. Graphical presentation. Definition. Are pictorial representations of certain quantities to effectively communicate certain characteristics of the data. Can be used for the following reasons. To visually summarize variables. To highlight a particular statement, and appeals to visual memory in ways tables cannot. Their selection depends on the number, level of measurement, and objective of presenting the data. Advantages versus disadvantages. Advantages. Simplify and convey the findings easily. Can make the data more convincing and engage the audience better. Disadvantages. Limited details in information. Approximate values. Required more resources, and interpretation may be subjective. Guidelines. Must be self-explanatory. ASCII. Alt. Appropriate placement of labels of legends. ASCII. Alt. Appropriate grids of guide rulings. ASCII. Alt. Equally spaced. ASCII. Alt. Pie chart. Give an idea of distribution. Make use of circles subdivided into a number of slices. Represents the relative proportion of the data falling into a given category. Angle of each wedge equals percentage contribution. A slice may be exploded or extended. Limit slices to minimum of 3, maximum of 8. Number of variables, 1. Variable type, categorical. Objective, distribution. ASCII. Alt. Bar chart. Consist of bars with similar sizes and with gaps between bars to emphasize discontinuity between data classes. If without space equals histogram. Compare absolute or relative counts between categories. Can be presented as simple, multiple, or stacked bars. Heights of bars equals quantity of the variables. Tends to follow certain guidelines. Equal width of bars. With unequal number of observations, use percentages. Bars are either colored or shaded. Figure 3. Leading causes of death among adults in region X, number of variables, 1, variable type, categorical, objective, distribution/comparison. ASCII. Alt. Figure 4. Distribution of preschool children across households in town X, number of variables, 1, variable type, discrete, objective, distribution/comparison. ASCII. Alt. Component bar chart. An extension of the simple bar graph. Uses bars divided into mutually exclusive categories of another classifying variable. May not be practical in comparing relative sizes across bars. Number of variables, 2. Variable type, both. Objective, comparison. ASCII. Alt. Percentage bar chart. Makes use of bars of equal length divided into mutually exclusive categories of another variable. Useful in comparing proportions across bars. Number of variables, 2. Variable type, categorical. Objective, comparison. ASCII. Alt. Multiple bar chart. Uses grouped bars are used to represent related data sets. Each bar in a group is a category of another classifying variable, or another variable altogether. Number of variables, greater than or equals / 2. Variable type, both. Objective, comparison. ASCII. Alt. Histogram. Used to depict number or relative frequencies of data points in a given class. Do not have gaps between rectangles / bars. Horizontal axis equals continuous measure of a variable. Vertical axis equals number or relative frequency. Are preferred for grouped interval data. Number of variables, 1. Variable type, continuous. Objective, distribution. ASCII. Alt. Box plots. Used to show characteristics of a large quantitative data, also called a box and whisker plot. Used to compare the distributions of several quantitative variables on the same scale. Number of variables, 1. Variable type, continuous. Objective, distribution. ASCII. Alt. Upper whisker, maximum value, third quartile, second quartile, medium value, first quartile, and lower whisker, minimum value. ASCII. Alt. Outliers. ASCII. Alt. Line graphs. Are plots of dots joined with lines over a period of time. Also called time series charts. Used to demonstrate changes in a variable over time, with time presented in the x-axis. Number of variables, 1. Variable type, numerical. Objective, time, trend. ASCII. Alt. Scatterplots. Are used to show relationship between two quantitative, continuous, variables. Gives a rough estimate of the type and degree of correlation between the variables. Number of variables, 2. Variable type, continuous. Objective, association. ASCII. Alt. Guidelines in presenting data. Number of variables presented should be kept to a minimum. Codes, abbreviations, or symbols should be explained in detail using footnotes. Each row, column, or graphical object should be labeled concisely and clearly, and totaled clearly. The specific units of measure for the data variables should be provided. Information on tables and graphs should be consistent and relevant with the accompanying textual discussion. Check and review the denominators used when computing percentages.